So in this problem here, we have 10 identical discs. The 2 of them are black and the rest are white. And they're drawn at random from the bag and not replaced. That's an important value. Let G be the number of discs drawn until the first black one is drawn. And we have to do the probability distribution and then find the expected value. I probably won't go through the whole process, but I'll do most of it. And then B part says, instead of replacing each dish, it's not. So this is basically the same question, but all over again. And then the C part just wants you to show that the probabilities are 1 for both if you replace it and if you don't replace it, which we'll see if I get to doing that one or not. So let's talk about the first one. So if we consider this, right, we know we reach into the bag and we can either pull a black disc or a white disc. The probability of pulling a black disc is 2 out of 10, and this is 8 out of 10. If I pull this black disc here, if I go this path here, I am finished. And so that's my first scenario. However, if I don't, then I'm going to pull a black and a white, and this is going to be, there's going to be a 2 out of 9 and a 7 out of 9. And then this could also go to a 2 out of 8 and a 6 out of 8 and a 2 out of 7 and a 5 out of 7 and a 2 out of 6 and a 4 out of 6. And this could be a 2 out of 5, and this could be a 3 out of 5. And this could then, this keeps on going, okay? And I'm going to keep on going through the whole process of all the possibilities. And then we'll make a probability distribution. So this is 2 out of 4. And then I could do black and white, and this is going to be a 1 out of 3, and this is a 2 out of 3. And then finally, this is going to be a 0 out of 2. And so I must do a black one this time when there's only not 1 out of 2, but rather I must do a scenario where I have 2 left and they are both black. Okay, so let's take a look and see what we all have here now. So that's my tree diagram, and I want to make a probability distribution where G is the number of discs drawn until the first black one is drawn. Well, so I could have G equal to G. Well, it could be 1. I pull it on the first time. My probability of pulling it on the first time is 2 out of 10. So the probability that G is equal to 1 is 2 out of 10. And I could, if it takes 2, 3, 4, and so on, so 2, if it's going to be 2, then what I'm going to do is it's going to end up being, I'm going to go, this is 2 different paths, so 8 out of 10 times 2 out of 9. That there is how I get to 2. So as I said, 2 out of, what did I say? 8 out of 10 and 2 out of 9 and 8 out of 10. When I go to 3, 3 is going to be 8 out of 10, 7 out of 9, and then 2 out of 8. And so if I do this probability, so as I said, I said 8 out of 10, 7 out of 9, and then 2 out of 8. 2 out of 8. And the next one's going to be, go into this path, it's going to be the same scenario, but it's going to be those 4 multiplied, and so I get 8 out of 10, 7 out of 9, 6 out of 8, and then I'm going to go times 2 out of 6, 2 out of 7, 2 out of 7. Okay, and so let's do some simplifying now. So if I come along here and if I simplify some of these, I know that this that cancels and that cancels. And so I have 2 times 4 is 14 out of 90, which I also know is 7 out of 45. And I can simplify this to 1/5, which is going to be 9 out of 45. And I only know this because I've seen the answer that it's going to be a nice pattern. If I cancel here, that becomes this. This is a 5. And I get 8 out of 45. When I start canceling here, and that 6 becomes a 2, and that becomes a 3, and that becomes a 1, and that becomes a 5. And the 7 and the 7, they just cancel, and so I have 2 out of 15, which if I multiply by 3 over 3 is going to be 6 over 45. So I can clearly see what the pattern is going to be. So I know that this one here is going to be 9 out of 45. This is 8 out of 45, 7 out of 45, 6 out of 45, and continuing this on. So it's going to be 5, 6, 7, 8. And so I get 5 out of 45, 4 out of 45, 3 out of 45, and then 2 out of 45. And so just, I think it's 8 is the last one. So is it possible I could have went 1 draw, 2 draws, 3 draws, 4 draws, 5 draws, 6 draws, 7 draws, 8 draws. Oh, 9 draws is the last possibility that it could be. So I have to go one more scenario, which gives me 9, which that probably is going to be 1 out of 45. And so this is the probability distribution here. If I want to find the expected value of G, well, that's going to be the expected value of G is going to be the 1 times 9 out of 45 plus 2 times 8 out of 45 times 3 times, that's this scenario here, times 7 out of 45, all the way up to and including plus 9 out of, 9 times 1 over 45. And I will add all those up, and that will be my expected value. And this is indeed what we call the probability distribution of g of x. Okay, and show that all the cases, sum of the probability is equal to 1. Well, if I look at that, if I consider the scenario 9 plus 8 plus 7, so all these values here, all the way up to plus 2 plus 1, well, that is going to be 10, 20, 30, 45, so it's 45 over 45, which equals 1. So that is true. So that's a part. When we got to do this different scenario, when we replace them, what's going to happen in this case is you are going to get an infinite geometric series, because this game can go on forever, and you can work out the probability for that. Let me know if you need more.